Okay. So if you look into it, this is a triangular prism, and in that triangular prism we have, this is called the angle of prism. Because it is equilateral, so angle of prism is always 60°. Okay. Now when a light falls on one of its face, then because it enters from air to denser medium, so refraction takes place and it bends towards the normal. And when again it is striking this face, it is coming out into air, so it moves away from the normal. And in this process, white light, which is combination of 7 different colors, gets scattered into 7 colors. I have marked only 2 colors, one is violet, other one is red. Now you know a pattern which is Vibgyor, Vibgyor. These are the 7 different colors, and in that you see the violet color deviates max and red color deviates least. If somebody asks you the answer to the question, the answer can be the wavelength of red color. Wavelength of red is maximum or more than any other colors. Okay. So wavelength of red is maximum or more than any other color. So the red deviates least. Okay. And violet having least wavelength. Violet color having least wavelength, so it deviates maximum. This is the answer. Okay. And the 7 different colors obtained on the screen, these 7 different colors obtained on the screen is called spectrum. Okay, we call it spectrum. Fine. Now if you see, there's some other aspect of refraction, and that we call it atmospheric refraction. What? Atmospheric refraction. Now, to answer this atmospheric refraction, we can take few examples. Like if you start with the twinkling of stars. Okay, when you look into the sky, and when it is clear sky, especially at night, then many stars are visible, but relative position of the stars are shifting from its original position. It's not fixed like stationary like. Why? Because let's draw these 2 lines, and just imagine the uppermost part is air. After that we have water, and then we have this which is called something more denser medium, and just imagine this is glass. Okay, fine. Are you getting? Hello. Okay, now if light is striking this surface, now light will be entering from air to water, so what will happen? It will be little closer to the normal. Fine. Now it is moving into the glass, which is more denser, so it would be more closer to the normal. So what is happening? Respective position of the light is changing, and that is why if this is the star or anything, its position appears to be shifting or changing. Hello, are you getting? So what could be the answer? Let's say this is the question, that the why stars appear to be twinkling. Answer would be because light passes through different medium into the atmosphere, and so it shifts from its position, and that way its relative position appears to be changing, and so it twinkles. Are you getting? Can anybody?
Yeah.
Can anyone repeat? What did I explain? Yes.
Sir, twinkling of stars happen due to the as light travels from different mediums through the atmosphere.
Yes. Different medium means having different optical density. Correct answer. Different optical density. Optical density is what? This is not mass per unit volume, but this is what? The speed of light. Speed of light is max in vacuum as well as in air, right? And if any medium optical density is less, then that is called optically denser medium. Okay? Hello.
Yes, sir.
Yes, sir. Now, next, let's say the atmospheric refraction is itself is a big, chapter. In that, if you see, you can relate it in daily life. Let's say, if you look into the free space, you will find the space looks blue in color. Okay, the color of sky is blue. Why? Anybody? Color of sky is blue. What could be the reason? Sorry?
Scattering of light.
Okay, scattering. What is this scattering? Color of sky is blue, right? Scattering of light is fine, but before that, we need to understand some basics of that. What is that? Let us look into it. Should I rub this? Hello? Should I rub this?
Yes, sir.
Yes, sir. When we talk about this scattering, what is dictionary meaning of scattering? Dictionary meaning of scattering. Sorry? Please repeat. I'm not getting. Means when things are not arranged, in a particular way, a specific way. Then we call the things scattered here and there, lying here and there. When we talk about light, this light has basically two components. What? It has two components. One is perpendicular to the plane and the other one is parallel to the plane. Are you getting? Hello?
Yes, sir.
There are two components. One is parallel component to the plane and other one perpendicular to the plane. And if we can have a mechanism to separate these two components, then this is called scattering of light. Okay? Okay? And how does it happen? How does it happen? All of you look into it. Now you see over here I have drawn, I am showing two parallel arrow. Two arrows are, okay? Here two dots are there. These dots are called perpendicular component of light and these arrows are the parallel components. over here, both are combined in this. What? Scatterer. Okay, scatterer like dust particles or atoms or molecules, very fine particles when they strike. Okay, hello. When they strike, very fine particles. Then light basically is what? Light basically is what? Light is energy. Light is energy. And let's say light strikes this surface of this mobile, and assuming some amount of light is being absorbed by this. So this mobile, actually the dust particle or scatterers, when some amount of intensity of light is absorbed, energy is something which is not going to be static. So it will be re-radiated from this. And in the process of re-radiation, the components are getting separated. And this is called scattering of light. Are you getting?
Yes,
hello?
Yes, sir.
Okay. So what is the condition? The size of this scatterer or dust or something, it should be comparable to the wavelength of light. It should be comparable to the wavelength of light. Fine. Hello. Yes. Now, due to this scattering only, the relation is the intensity of scattered light is proportional to 1 divided by lambda raised to the power 4. This symbol lambda, you know, na?
Yes, sir.
Lambda stands for wavelength. You ignore the lambda raised to power 4, but you can remember that the intensity of light is proportional to 1 by lambda raised to the power 4. Means higher the lambda, lesser will be the intensity. Okay. Hello. More will be the value of lambda in maximum wavelength. Just we have done. Which red color. So red does not scatter, or scattering in red color is least, and so red color is used as traffic signals to stop vehicles and other things, because that red signal can be seen from longer distance. Okay. Now the next, the blue color, because blue is the intermediate color, means बीच वाली color है ये. Blue कैसी है? Intermediate color, बीच वाली, means comparatively it has lesser wavelength, and so mathematically, you know, if this value is less, denominator this side, the value will be higher. Okay. So after this formula and diagram, you can add. Please add. All have drawn this diagram.
Yes, sir.
And this formula have you written? This formula is visible. Capital
Yes,
I proportional to 1 by lambda raised to the power 4. This is called intensity of light. And then add, since red color having maximum wavelength, since red color having maximum wavelength, so it scatters least. So it scatters least. And then next sentence, this is the reason a red color is used as traffic signals. A red color is used for traffic signals because it can be visible from long distance. It can be visible from long distance. Okay. Then next, all of you add. Next is, since blue color having intermediate wavelength or lesser wavelength, since blue color having intermediate or lesser wavelength, so it scatters maximum. So it scatters maximum. Okay.
Yes, sir.
Done?
Yes, sir.
Done now?
Yes, sir.
You can take some other examples also from daily life. Like if you see during rainy season, right? Rainy season, space is not clear, sky is not clear. So you can see some clouds over there. And generally clouds are white in colors. Okay. So what is the logic behind this? When something is seen white, white means that contains all the colors. So those clouds which are appears to be red, it means it contains all the colors, or white light after striking the dust particles or something, not only red or blue is scattered, but all 7 colors getting scattered. So when it's a mixture of all colors, so it is seen to be white. Okay. Okay. And what is the theory behind that? What is called black? Something visible black. Due to which reason? Black means no reflection. No reflection. Right? So from my side, this was the overview of this refraction through mirrors, refraction through lens, then glass prism, and some idea about scattering and atmospheric refraction. Do you want to ask something? Anybody want to ask something? And this way we have overall we have taken I have given overview of entire syllabus, all the chapters. Okay. Hello. Now anything, if any question you can ask, but one by one. Ask.
Sir, can you explain Tyndall effect?
Sorry.
Tyndall effect. Tyndall effect.
Yes, correct. So Tyndall effect in your standard, what we call Tyndall effect, same thing is atmospheric refraction, and same thing is what we call scattering of light. The standard name of Tyndall effect is scattering of light. So when white light strikes the dust particles or the scatterers or the molecules of same size, equivalent size, then light gets scattered. Is called Tyndall effect. It happens generally in atmosphere. It cannot happen in vacuum. Why it cannot happen in vacuum? Anyone? Sorry.
There are no particles in vacuum.
Yes, correct. Correct. So in 10th we call it Tyndall effect, and in higher classes we call it scattering of light. Only this is the difference. Okay? Good question. Good question. Any other question? Yes? No question? No question? So can we end our meeting? Yes? So we have done the overview of the entire syllabus. Thank you so much. Yes.
Doubt about rainbow formation.
Yes. Again, good question. I'm showing it with the help of the diagram. Okay?
Yes, sir.
When we talk about rainbow, then what we drawn in the previous few minutes back, which was the diffraction through a glass slab, okay, or refraction through a glass prism. Fine. So in the atmosphere there are raindrops. Yes or no?
Yes, sir.
And raindrops act like glass prism. Okay, glass prism. So during rainy season, what happens? Let's say this is a raindrop. A ray of light, let's say it strikes this raindrop. When it will strike, what will happen? Inside there is water now. So air to water, light is entering. So medium is changing. So it is getting refracted over here. And this angle of incidence over here is less than its critical angle. So in place of moving out, it again gets reflected. First refraction over here, point number 1 is refraction. Over here, point number 2, reflection, and then finally it comes out of it, which is refraction. So there are 3 things involved with this. What is? First is called dispersion of light. So we will write rainbow is formed due to dispersion of light. Second point is inside it 2 times or double refraction. Whatever you want, you can write 2 times or double refraction. And I think there was some technical issue, so it got disconnected. Right? The diagram is also gone. So basically, we need to tell that the first dispersion takes place, okay, dispersion of light. Second, double refraction, and third is internal reflection. Internal reflection. So these are the reason or cause behind the formation of rainbow. First line, it is due to dispersion of light. When a ray of light strikes any of its surface, then refraction takes place, and inside it is getting reflected, which is called internal reflection, and finally it is coming out after refraction. So refraction 2 times, so double refraction, and reflection 1 time, so internal refraction, and thus rainbow is formed.